All right, let's start by proving De Morgan's theorem. That's not too difficult to prove. You just say E I theta, make a Taylor series expansion. So that's 1 plus I theta plus I theta squared over 2 plus 2 factorial plus I theta cubed over 3 factorial, etc. That's equal to 1 plus I theta minus theta squared over 2 factorial minus I theta cubed over 3 factorial. That's equal to 1 minus theta squared over 2 factorial plus etc, etc. And then if you take the I out of all the imaginary terms, you get theta minus theta cubed. I think theta minus theta cubed over 3 factorial, yeah, that's it, etc. And what you notice is that this first series here, that is for cos theta, and the second series, that's for I sine theta. So that means EI theta is equal to cos theta plus I sine theta. If you power n both sides, then you end up saying that cos theta plus I sine theta power n is equal to EI theta n, which, to be clear, is E power I times theta n. So all that's happened is that in this formula here, theta has been replaced by theta n. So likewise, the theta here gets replaced by theta n. So that becomes cos n theta plus I sine n theta. So that's the first part of this question done. That's the proof of De Morgan's theorem using Taylor series. Secondly, we want to prove now that z power n plus z power minus n, that's equal to 2 cos n theta. So using De Morgan's theorem, that's cos n theta plus I sine n theta plus cos minus n theta plus I sine minus n theta. That's equal to cos n theta plus I sine n theta. Cos is even, so we can ignore the sign on the argument, so that's cos n theta, and sine is odd, so that lets us take the minus out. And so they cancel, and you're left with 2 cos n theta. So that's the second part done. Now, the third part is we want to do something similar. We want to find sine. So if you look at what's happened here, you can see that with just a change of the signs, we might be able to get it. So if you look here, Zn minus Z power minus n, I think if we divide that by 2, so that should be it. That's going to be cos n theta plus I sine n theta minus cos minus n theta minus I sine minus n theta over 2. So that's cos n theta plus I sine n theta minus cos n theta plus I sine n theta, using the same logic as before. Cos is an even function and sine is an odd function. The cos's cancel, so you're left with 2I sine n theta over 2, which is equal to I sine n theta. So to fix it, I'll just put an I here, dividing by I. So that's equal to sine n theta. So sine n theta in terms of z is this expression here. Okay, good. And lastly, we want to prove this. Okay, so not cos actually. Sine x plus I cos x power n. That's equal to, I'll take the I out, and if you divide by I, you're left with minus I sine x plus cos x power n. So that's equal to I times cos x minus I sine x power n. And again, using the fact that cos is even and sine is odd, that can be written as cos minus x plus I sine minus x power n. We'll write I in polar form. That's cos pi over 2, which is 0, plus I sine pi over 2, which is 1, I. And then that's multiplied by cos minus x plus I sine minus x. When you multiply numbers in polar form, you add the argument. So this becomes cos pi over 2 minus x plus I sine pi over 2 minus x power n. Use de Morgan's theorem. That's cos n pi over 2 minus x plus I sine n pi over 2 minus x. So prove de Morgan's theorem, done. If z equals that, prove that zn plus z power minus n equals 2 cos n theta, that's done. Find sine n theta, that's done. Prove that, that's done. Okay, now I think that's the whole question was all just proofs. It's just nothing but proofs. I don't think I've seen a complex numbers question that is fully just proofs with no calculations or equations to solve or anything. So that's kind of a good revision question for practicing proofs. Okay.